today's objectives are we're going to find distance, midpoint, and intercepts. And we're going to graph with intercepts and vertical and horizontal lines. Alright, so the rectangular Cartesian coordinate plane is split into 4 quadrants. We start in the top right with quadrant 1, and then which direction do we go? Yeah, counterclockwise, left. So then we have 2, 3, and 4, just to kind of remember quadrants. Yeah. Okay, who remembers the distance formula? All of this should be lots of review today. Really refreshing our minds. Distance equals y to what did you say it was? So you have a square root going on. That's quadratic formula.
Just kidding.
You have 2 things being squared with an addition. So you have x2 minus x1 and y2 minus y1. Give me 1 second.
Oh, obviously. No, I know. Yes.
Yeah.
Yeah.
Immediately. I get homework, matrix, my homework problem.
Yeah. Even on like the last week that we had, I was going. And you got I didn't check. I was like, you're so no, like really like on time.
I think that like okay. So how did we get this Pythagorean theorem? Let's kind of talk about it. Let's go and pick 2 points. Okay. So we can call this point at x1, y1, comma, y1. And we'll call this point x2, y2. Okay? So if I want to find the distance between these 2 guys, that's what I'm looking for, the distance between 2 points. So I'm going to go ahead and make a right triangle. And what's the Pythagorean theorem? Do you remember for a right triangle? What's the Pythagorean theorem? A squared plus b squared equals. That's basically where the distance formula came from. So here, this distance would be the top minus bottom, right? For that whole length, kind of like if this was 6 and this was 4, what would be the distance between 6 and 4? 2. So you take top minus bottom to get the distance. So y2 minus y1. This distance right here be right minus left. Kind of like if I had 5 and 1 as my two x values, the distance would be 4. So I have x2 minus x1. So putting all of that into the Pythagorean theorem. What's your A in this case? Well, it would be 4 if it was 5 and 1, but that was just like a general case. Or a specific case. In general, yeah, you have x sub 2 minus x sub 1. So that's kind of like our A. What's our B going on? Y sub 2 minus y sub 1. And what's our C? D. So we have a squared plus b squared equals c squared, right?
Hold on.
Okay, I will.
I'm still really confused on the y2 minus the y1 and stuff. Like, what are we doing? Like,
The 6 minus 4.
no. Like, why on the green? Like, yeah, in the green part of the triangle. Why did you bracket and then put the
This
y2?
distance right here in general. If I was to be specific and say this y was a 6 and this y right here was a 4, this distance would be 6 minus 4, which is 2, right? But I'm not going to be specific. I'm going to say in general, this y is y sub 2. This y value is y sub 1.
Oh,
So
then
to
you
get
just do
the distance, you subtract them.
Oh.
Yes. Okay. So now that I have that, I want to just know the distance. So I have to get rid of the square. So to get rid of a square, what do you do? Square root with a plus or minus, right? Anytime you square root. However, distance is always what? So we don't worry about the negative when we go say d is now, the square and square root will cancel, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And that's where it came from. Let me ask you a really important question because so many students want to do this. Can you, just like we canceled here, the square root and the square, can you cancel the square root with these squares? No, you cannot. Because you cannot go over addition. Okay? It'd kind of be like saying when we had something like this, can you distribute that? No. Right? That does not equal x squared plus y squared. It equals x plus y times x plus y. And if you FOILed, you would get x squared plus 2xy plus y squared. Are these the same? No. You cannot distribute any kind of exponent, and a square root is an exponent of a half, when you have addition or subtraction. Okay? So you cannot distribute. You have to leave it with the square root and with the squares. See if anybody at your table has questions. Okay. Midpoint formula. If you're going to find the midpoint, first off, this is going to be a point. Okay? So point is x comma y. You're going to average the x's and average the y's. That's all you do for midpoint. You take the average of both of those. So in general, this midpoint formula, okay, so your midpoint formula, again, it is a point, so make sure you have a point. If you're going to take the average of the x's, what would you do? Well, say I had two numbers, 4 and 6, and I want to find the average. What would you do? them together and divide by 2. So if you have any two x's, you're going to add them together and divide by 2. X of 2 over 2. Oh my gosh, where is the x sub 2 over 2? So your y's would be y sub 1 plus y sub 2 over 2. Okay, so let's do an example where we're going to find the midpoint and the distance. So here's 2 points. Let's find the midpoint first. Be sure it is a point. If you don't have parentheses, is it a point? No. So get your parentheses so I don't have to take off little notation points. Okay. So which one comes first? X's. Are we going to subtract them or add them? Add them. So I have -3 plus -6, and we divide by 2, because there's 2 of them there. With the y's, I have -4 plus 1 and divide by 2. Finish that out, and what do you get? -3 plus a -6. -9 over 2. Can you reduce that? So leave it -9 over 2. -4 plus 3, or plus 1. -3 over 2. Can you reduce it? So -3 halves. Everybody okay with that? All right. Distance. The first thing I would do, okay, is label. This is my x1. This is my y1. This is my x2. This is my y2. Like, organize yourself a little bit. Then I know I'm going to have something, something, squared, squared, right? What sign goes in the middle here? A plus. Think of the Pythagorean theorem. It's a squared plus b squared. Then what am I going to do in the middle of this one? What goes here? X sub 2 plus or minus? Minus x sub 1. Because you're finding a distance, so you have to subtract. Like the end minus the initial. So we're going to have -6 minus a -3 would make that a plus 3. Right here, we're going to put y sub 2 minus y sub 1, which would be 1 minus a -4 is plus 4. Do all your inside, then look at the square root part. So simplify all the inside. Yes. Yes. There's something else. Is there any perfect squares for parents on? No, I don't. Maybe I should use mine. So this is what you should get. Does anybody want me to do more work? I don't mind, just tell me. Everybody get that?
You could do it right. This one on this one. Oh no, you just said to get off the button.
Okay, can we simplify that? Is there a perfect square that divides into 34 that we can make it in? No, so we're good. Alright? Alright. Let's do red. So a linear equation in 2 variables just means you have something like y equals 2x plus 5. So you have a linear equation in 2 variables. And which one is the independent variable and which one is the dependent variable? What's independent? What's dependent? Which one are you plugging stuff in for? Like when you go to graph a line and you make a chart like this, right? Which one do you plug it in first? Okay, so you get to pick your x's, right? That's independent. You get to pick what you want. So your independent is your x. Now, depending on what you pick, you get out a y value, right? So y is dependent upon the x. So your dependent is your y. Okay. So you pick the x's, and they determine the y's. That's why the y is dependent. How many points determine a line? 2. All right, x and y intercepts. What do you guys remember from those? This feels like a Monday in here. Wednesday. X and y intercepts. Okay, so y equals mx plus b. That's the y-intercept, right? Okay, what else do we remember? Anything else about x? No, but thank you for trying. What do you remember about x and y intercepts? I just want to know, what do you remember? What if I draw a graph? Let's start there. I'm going to draw a line. Carly, come on down. You look so pretty today. You need to be up in front of it, right? Okay. It's really, really easy. It's on green right now. Here you go. Put a dot where the x-intercept is. Put a dot. Told you it was easy, right? Okay. Thank you. So there's your x-intercept, right? Your x-intercept is when what happens? You do what? Yeah, you cross the x-axis. You intercept the x-axis. So where the line crosses the x-axis. And no matter what, think about if I drew a different line. Carly, can you put it in? Put it on green. It's so much easier than like popping off a cat, putting it on colors. Show it to me again. Where's the x-intercept? Awesome. One more time. Hold on. Right. One more. Where's the x-intercept? Okay. No matter what, the x-intercept has a y value of what? 0. Do you agree with that? So you find this by plugging in y to be 0. Y is always 0. So you plug 0 in to find out what's your x. Well, plug y to be 0 to find out. Is that okay? So we're going to write this as a point. Our y is always 0. And then we go find our x-intercept, whatever that number may be. Okay? So the y-intercept, this is awesome if it's already in this intercept form, then you can just say this would be the y-intercept b, right? And what would your x be? The y-intercept. 0, okay? And so if you already have that part, that's great. But otherwise, the y-intercept in general is where the graph does what? Crosses the y-axis. Okay, so we find it by plugging in what to be 0? X. And we will write this as a point. Zero is always x, whatever number we get out for b. And I don't know if you guys have heard of like the cover-up method. Like let's just say I had 5x plus 2y equals 10, right? If I wanted to, I could cover up. Let's see if I can. Oh, that's the magic eraser. Let's cover it up with flowers. Okay. So if I wanted to find the x-intercept, when I plug y into be 0, I cover that up, and what does x have to be? 2. So what's your x-intercept here? 2, comma, 0. Does that make sense? Otherwise, what did we have before? 5x plus 2y equals 10. If you wanted to find the y-intercept, what would you cover up? The x. So I just kind of put my hand over it, but cover up the x, solve for y, what do you get? 5. So here I know that I have 0, 5. When it's in standard form like that, that's how I solve them. I kind of cover it up. Do you like that? Yeah. Okay. So, find all intercepts. This first one's kind of tricky. Do you have an x and a y? So what can you find? Your x-intercept? See, discuss it with your table. See what you can think. What's your x and y-intercept on this first one? See what your members think. So think about the cover-up, right? So for your x-intercept, for your y-intercept. For your x-intercept, what are you going to cover up? Nothing. There's no y. So basically, there's nothing to shade out, right? So you can just solve for x. So go ahead and solve for x. So let's see, we can reduce that to -1/8. So what's your x-intercept? Write it as a point for me. Huh? -1/8, 0. Write that as a point. Star that, whatever you need to do to say, Mr. Rose likes you to write the intercepts as points to get full credit. Okay? Now the y-intercept, what do I cover up? I cover up the x part. And then we go solve, right? So when I go solve, I get this. E. What does that mean? Do you have a y-intercept? No. And I did the cover up because somebody said they liked that, so yeah. So there are your intercepts. Anybody remember what kind of graph that looks like? We're going to get to it in a second. Huh? Anybody remember what kind of graph that would be? Vertical. Yes, it is. Good job. Okay, do the next one with your group. Go. They're not related. Lena, what'd you get for your x-intercept? I won't pick anything that you're saying. Let's go to Kara. Kara, what'd you get for your x-intercept? Everybody get that. Put parentheses around it. And what'd you get for your y-intercept? 0 to 10. Did everybody get that? Does anybody need me to show more work on that? I do not mind. Just let me know. Okay, for the x-intercept. So I'm going to start with 2x plus 3y equals 30. I'm going to go, and if I want to find the x-intercept, I'm going to cover up my y. Yeah? Now it says, hey, go graph it. Okay. What do you want to make your tick marks go by? We got to go to 10s and 15. 5s, perfect. 5, 10, 15, 20. 5, 10, 15, 20. Okay, I kind of want a little extra just so we can see. So if I have an x and Carly, you're up. Oh my gosh. Okay. X and y intercepts. This is you. If I have an x-intercept of 15, 0, can you plot that for me? Just make your dot. Awesome. And your y-intercept 0, 10. Awesome. And then what do you do? Guys want a good time? Woo! Carly. How'd you guys do? Thumbs up? What do we got? We got one more, and then we're done with the 3, 1, 11, 2, and then we just have 3, 2 left. And that should go pretty quickly. So, we'll get a little break after this. Huh? No, like a little dance break. This right here, and then we'll take a small little break, and then we'll finish up with retail. Okay. Graphing vertical lines and graphing horizontal lines. That last one, Melissa said it was vertical. This is how I remember it. I have little mnemonic devices inside my head at all times because there's so much math going on. To remember everything is ridiculous in the world. So I have to connect it and have mnemonic devices. So, hoi, right? Hoi is the first one. Hoi means horizontal line. 0 slope, y equals a number. So hoi is my first one. And my next one that I remember is bucks. So hoi bucks. And it's being recorded. Okay. So this is a vertical line. It has an undefined slope. Let's put M for slope. I ran out of room. And it is x equals a number. Okay. So here, if I'm going to graph vertical lines, I'm going to have x equals some number. I'm going to make what kind of line? Vertical. Okay, wherever that number is. And what kind of slope does it have? Undefined. So let's do a quick example. What's your favorite number? 10 equals 20. What do you first have to do? Solve for x. So what's x equal to? What kind of line is it if it's x equals? Vertical line going through what value? 2. Is that okay? So a horizontal line is going to just be y equals a number. So basically here, there are no y's, and here there are no x's. Okay? When you have x's and y's, it's when you get the lines we were just looking at. So when I go do it, a horizontal line for boy, going through whatever number you are talking about, and here our slope is 0. So again, a little example. To that one. Do you see any x's? Nope. So what do you need to solve for? Y. So solve for y. What's y equal to? -6. Y equals a number means it is what kind of line? Horizontal line going through -6 on the x or the y? On the y, because you're dealing with the y. So you're going to go through, and what kind of slope does this have? Has a slope, it's just it's 0. The way I remember it is I'm like, can I walk on this? I can walk like this, right?
I wouldn't walk like that.
Okay, but you can do it, you just don't have an incline. Can you walk like this? You could not. Not possible, can't do it, undefined. Okay? All right, take about a 2-minute break, and then we'll finish up. I don't. You guys didn't have one for me. Yeah. All right. I'm suggesting that yeah. I don't know. I thought it must be. I'm really sorry. Because I think you know but it seems if it was me, I would. Because I'm pretty sure I'll forget that last week. So definitely not trying.
Yeah, I know. No, I didn't.
Stand up, stretch it out. It's blood flowing. I thought we were going to jam it in. Boom. You want that one? Yes. Gosh.
11 pages of it.
Trouble.
I should probably pause this for Kenzie too, huh?
All right, so now in degree 2, we're going to be doing some slope. So we're going to find the slope from 2 points or a graph and parallel and perpendicular slopes. Is it okay if I just write N for slope? Okay. Find N from 2 points or a graph. And find parallel and perpendicular slopes. And then find parallel and perpendicular slopes. Perpendicular, you make two perpendicular lines. Or you can if you want to write it out. Okay, well, yes.
Oh, never mind.
Are you sure?
You're probably going to explain. was just gonna do it. Is it parallel pretty much so you took a line or something?
Okay, what's m equal to? Give me one formula. y2 minus y1 over x2 minus x1. Good. What else? Could I do y1 minus y2? If I do that, what do I have to do on bottom then? Yeah, the ones have to be together and the twos have to be together. What's like if you're looking at a graph, you go blank over rise over rest. Once you start getting up, you can say change in y over change in x. So the little delta sign means change. So basically, slope is a rate of change. Yes. When you print, you'll have to like it's under a property like to print front and back. Oh, okay. Yeah. All right. So slope is just meaning that you have a rate of change. So what does slope from this graph tell us? So we're kind of looking at this graph as we go. What are we finding as you go along? Well, this is minutes, this is cost, right? The cost per minute. Awesome. Okay? So you can find like how much it costs per minute for this dial-a-no to go wireless. All right. So let's determine the slope of this line. Is it positive or negative first off? It is negative. Think about your little self, okay? Here you are. You're standing up here and you're going to go skiing, right? Are you going to go down or do you have to go up? You're going to go down, right? You're always going left to right. Okay? So this slope has to be a negative slope, first off. We know that. So now we can just kind of use the rise over run. So we went down 1, 2, 3, over 1, 2. So if you're saying down, you can think of that as the negative, or you can just say, I know this slope is negative. My final answer better be negative. Okay? Like this. This slope has to be what? Positive. Because here you are, you have to travel left to right. So as you're going, you have to go up. Okay? So this one would have to be positive. Okay, now what if I gave you 2 points? What equation would you use? Yeah, go for it. Go find that slope. You guys can do this. You've been doing slope for a while, right? Yes. Is that all right? Go to the slope. So go do 2 and 3, and if you have questions, I'll come around and help. Work on 2 and 3. I wouldn't
something like that.
Just gonna help you with your notation, because especially if you go zero, it's not
Wait, so it's not whenever zero. Yeah.
Okay. So my little mnemonic device, if you have a number over zero, it is no. Okay? So this is going to be an undefined slope. So what kind of line is it? Vertical line. Okay? What kind of equation is it? X equals or Y equals? X equals, plus, right? Vertical, undefined, X equals. Okay, do the next one. If you haven't already.
Wait, so is the answer you say is it vertical or is that defined?
The slope, it says find the slope.
Oh,
So this is your slope.
okay.
I was just asking you like the other stuff. Okay. This is now on the my device here. If you have 0 over a number, it is okay. So this one is a slope of 0. Put 0 over negative 10 in your calculator. Put negative 10 over 0 in your calculator. Do both of those. What does your calculator tell you? It actually helps you out. When you put 0 over negative 10, what do you get out?
Zero.
Okay, this one gives you 0. This one gives you a error. Boom, right there it's telling you it cannot do it, so it must be undefined. Alright. Parallel lines, and I remember this little guy right there with a parallel. Yes. If it's an emergency, otherwise you're not doing that. Okay. So parallel lines means that they have the same slope. Perpendicular lines have what? Opposite and so like if one of them was 7, the perpendicular slope would be what? Negative 1, 7. Yeah, probably. Oh, you guys can correct me a lot about that. I'll help you with your math. You can help me with stuff. Okay. Oh. All right. So, that's kind of what we were just doing in the example part, right? Okay. So let's look at this example. Find the slope of the line through -3, -5, perpendicular to the line through -2, 6, and 5, 3. They give us a lot of information. We need to go pick out what we are looking for, what we have, what we need. Okay? So what do we want? We're trying to find a what? A slope with our line going through what? -3, -5. And we know that this is going to be what? Perpendicular to the line going through -2, 6, and 5, 3, right? So what should I do first? Find the slope of what? Yeah, go find this slope. Can you find that one? Let's find the perpendicular slope. Did it ask me to find the line? Do I even need this piece of information? I don't. It It just wants what's our slope then have to be if it's perpendicular? Negative 7 over 3 or 7 over 3? Yeah, positive 7 over 3. Good job, kids. So that's our final answer. All right, last one. Okay, use slopes to determine whether these points are vertices of a right triangle. So if you have a right triangle, what do you know has to happen? This slope, right? And this slope right here has to be what? Perpendicular. So these guys have to be perpendicular slopes. So basically, you're going to go and see if you start finding all of these lines, like the slopes, do you find any that are perpendicular? So you kind of have three sets of things to do. What's the slope of this? What's the slope of this? What's the slope of this with those points? Let's sketch it a little bit, see if it helps. 0, 0, negative 1, 1, 2, 3, 4, 5, 6, negative 3, 3. So you're looking to see if this triangle that you're doing, if these slopes, so this slope, and so 1, this slope, and this slope, if any of them are perpendicular. That's what you're looking for. Because all right triangles must have a set of perpendicular slopes. So, go for it. Start finding some slopes. Find m sub 1. Find m sub 2. Find m sub 3. I don't care if you do it rise over run. I don't care if you do it with the change in y over change of x. I'm going to tell you what I got out, and then I'm going to see if you guys get these. So you work through and see if you get those. Any more direction, let me know. Okay. So if this is the point, this one is 2, 3, 3, and this one is 0, 0. So for my n sub 1, I'm going to do 0 minus 3 over 0 plus 3 basically. Right? Which equals negative 1. Does that help? So I can do change in y. 6 minus 3 over change of x. Negative 1 plus 3. Negative 1 minus negative 3. X1, Y1, X2, Y2. So 6 minus 3 over negative 1 minus negative 3. None of them are perpendicular, so no, it is not a right triangle. That is the finish of